Welcome back to your Algebra 1 Semester 1 final review. We're looking at problem 35 today, which is talking about a system of equations. And just a reminder that your problem might have a different number, but as long as it looks like the same numbers and all that, this video is a perfect follow along for you. Now, I'm actually going to show you a couple different ways to do this problem, and I'm not saying one is any better than another, but it's important to realize that you have options and they're never going to force you to do one way. However, one way might be easier than others. So when we solve a system of equations or multiple equations at once, we really usually have three different methods. We have a method with graphing, and graphing tends to be the one that people use the least. Graphing is nice as long as we have an equation, as long as we have both equations that are y equals, and they're very easy to graph. Now, neither of these have y equals, so I'm probably going to skip graphing for today. The second option is substitution. Substitution is a nice way to go as long as in your system of equations you have one variable that's completely alone. So maybe you have something like x equals, or you could have something like y equals, either variable alone. And you'll notice in our system over here we don't have a variable that's completely alone. X is close, but it's attached by negative 2y. So I am going to show you substitution, but not until the end. Instead, we're going to focus on our third method, which is going to be elimination. And the way we set up elimination is we want to make sure that our x's, our y's, and our equal signs are all lined up. It's going to make your life a little bit easier. So you're going to have some number with x up here, and you'll have a different number with x down here. Maybe there's a plus, maybe there's a minus, some number with y, and then your equal signs are going to be lined up, and there'll be numbers over here. Okay, and they could be in a different order too. As long as everything's lined up, though, you're good to go. So how does that help us? Well, let's look at this system first, and I'll show you one way that we can do elimination. X minus 2y equals 5, and we also have 3x plus 8y equals 1. Now, most people remember elimination. They say, oh, yeah, my teacher just said we just combine like terms. We go down, it's kind of like adding like terms. I'll put the invisible 1 here, and then we're good to go. But if you combine like terms, you're going to get 4x, 8 minus 2 is 6y, and a positive 5 and positive 1 makes positive 6. And that's not how we want to start elimination, because elimination needs to make one of these coefficients into a 0, and neither of them became 0 when I combined like terms. So before I start elimination, we need to do one extra step, and that extra step is we need to cancel one of our x's out, or one of our y's. So let's look at x's since I said that first. This is a 3x. 1x doesn't cancel out 3x because 1x isn't the number that adds to 3 to make 0. The number that adds to 3 to make 0 is one that you're going to say, oh yeah, duh. The number we want x to be is negative 3, because negative 3x and positive 3x are opposites. They'll cancel out. So if that's supposed to be a negative 3, let's turn it into a negative 3. And the way we do that is remembering that in algebra we're allowed to multiply by any number we want as long as we do it to both sides. I'm going to multiply 1 by negative 3 to turn this top equation into a negative 3x. I'm not going to do anything at all to the bottom equation. But of course, if I do this negative 3 to our first term to get negative 3x, we need to do that to everything. Negative 3 times negative 2y is positive 6y. Negative 3 times 5 is negative 15. And then we combine our like terms. So our x's are going to 0 out. 6 and 8 make, of course, 14y. And negative 15 and a positive 1, or 1 minus 15, make negative 14. Now that we've canceled out a variable, solving should be a little bit easier. All we need to do is divide off our 14 from in front of the y. We get 1y, but we know we don't write the 1, and we get y equals negative 1. Now be very careful here, because y equals negative 1 is not the same as x equals negative 1. They wanted an answer, they wanted an x. Well, when you fully solve a system of equations, your final answer will have two coordinates, an x and a y. We just found the y. The reason they're two coordinates is because really what we're doing, if you think about graphing, is we're seeing where the 2 points or the 2 lines cross, and where 2 lines cross has an x and a y. So let's get to it. We have the y. How do we find the x? Well, we go back to any of our original equations, or any equation you want that has an x and a y, and you replace the y with -1. So I'm just going to go ahead and take, I don't know, maybe this top equation, it doesn't matter, and that's going to give me x minus 2y equals 5, but as we mentioned, we already know what the y is supposed to be. The y is supposed to be -1. So it gives us x minus 2, and instead of y, we're replacing with -1. Same equation, but we know the y. Let's clean this up quickly. -2 times -1 is +2. And then to isolate x shouldn't be too terrible. Just subtract 2 from both sides, and we end up with x being equal to +3. And that gives us b. Now, this video is going to go on a little bit longer because I wanted to give you multiple options. And this second option I'm going to give you is another way to do elimination. In fact, it's the same way, but we're going to be a little bit more clever about that. So if you want to pause this video and write down what we have so far, great, because I'm going to erase this. I just want all the original problems up top so we can be a little bit smarter about our elimination choice, and then we'll go from there. So, elimination again. If we wanted to do elimination, which we just did, there's nothing wrong with it. But be smart. If you look at the answers and they're asking you for the y, or for the x like they are up here, then don't cancel out the x. Let's keep the x in the problem. And instead, let's get rid of the y, the thing they're not asking about. So looking at these two y's right here, it's usually easier to make the problem equal the bigger number, in this case this 8y. So you should be asking yourself, what does -2y have to become to cancel out +8y? And hopefully you're saying, ooh, if it was a -8y, that would cancel out the +8y, and then we'd be golden, and you would be right. So we need to turn the -2y in the top into a -8y. And here's how we do it. We take the top and we multiply what times -2 gives us -8. I think just 4 will work just fine, but let's double check. 4 times x, that's going to give us, of course, a 4x. 4 times -2y is -8y, and don't forget the right side, 4 times 5 is 20. The bottom's going to stay the same. And now we have a system of equations that we can solve by elimination. Let's see what happens when we add straight down or combine like terms. 4 plus 3 is 7x. Our y's will cancel. 20 plus 1 is 21. And now we just have the equation 7x equals 21. Solving's not too terrible. Divide by 7, which leaves us with x equals 3. Notice that this time we didn't have to plug our x back into an equation to find y, so there's actually less work doing it this way. But you also had to think a little bit ahead and say, well, which one do I want to keep? I want to keep the x because there's x's in the answer. Now, the other way, the third way that I promised I would show you is substitution, because substitution does work here. There's nothing wrong with it. So let's see how that would work. Again, if you want to pause the screen, go for it, but I'm going to show you how substitution would work. Substitution works, again, by making sure that one of the variables is by itself, either an x or a y. It doesn't matter which one. And so looking at this top equation, I think it'd be pretty easy to get this x by itself in the top equation. And we'd get it by itself by removing the -2y. Okay, so let's see, what does that give us? Those cancel. It leaves me with an x on the left side, and then I'm looking at a 5 plus 2y on the right side. So here's my new system of equations. The bottom didn't change. 3x plus 8y equals 1. The top did change. I had to manipulate. I had to use algebra to move our terms around to get x equals 5 plus 2y. Now, substitution works by realizing what an equal sign means. An equal sign means that the left side and the right side are the same. Even if they might look different, they're the same. It might be, oh, what's an easy example? Like if someone says potato versus potato, you know what they mean. You can use either one. But maybe a better example might be someone who asks for a pop, if you're living in the Midwest, versus a cola versus a soda. All three of those mean the same thing. It just, you use different words based on where you're living. And so we're going to do the same thing here. We have x, or we have 5 plus 2y. So if I had a sentence like, oh, I have x over here, Instead of saying I have x over here, you could say I have 5 plus 2y over here. They are the same because of the equal sign. And that becomes important right now. On the bottom equation, we have 3x plus 8y equals 1. But instead of x, because x is the same thing as what? Oh, right, x is the same thing as 5 plus 2y, then instead of writing x right here, I'm going to replace it with 5 plus 2y. Now that helps us because we now have this equation that only has y's in it, and we should be able to solve. If we distribute, 3 times 5 is 15, 3 times 2 gets us 6y plus 8y equals 1. Combine your like terms. For 6y's and 8y's gives you 14y's. And now start to isolate y. A 14 is multiplying, a 15 is adding. We know we undo addition and subtraction first. And so we get 14y equals negative 14, and then divide off. Divide by 14, divide by 14. That leaves us with y equals negative 1, which if you remember before when we used elimination, we also got a y of negative 1. Now, how do we find the x? Well, it's the same thing as before. We take this negative 1 and we go back to any equation that has both an x and a y and we plug in the y. And I would actually suggest not going back to the original here, because one of the nice parts with substitution is you're always going to have an equation that's a little bit easier to find the other variable, and that's going to be the equation that has a variable isolated. In this case, this equation right here. This is the equation x equals 5 plus 2y. And the nice part is when we plug in negative 1 right now, we don't have any algebra to do. We just have some arithmetic. We just have to multiply and divide, or multiply and add, and we should be good. 2 times negative 1 is negative 2. 5 minus 2 gets us that same x of 3. It really depends on the situation of which one is faster. In this case, I probably would have used elimination because the x's, the y's, and the equals are in a line and you can decide which variable to eliminate. But if the variable x had been by itself originally, I probably would have used substitution. So there's no one right way to do it. You have a whole bunch of options in front of you. Good luck.